Hello everyone, I'm Paolo and I'm working with Sviluppo Chimica from 20 years ago. This is a subsidiary from Federchimica. This subsidiary is a service company trying to follow suit like the institutional activities of the federation, try to support chemical developments and reinforce and strengthen the competitiveness of the chemical sector. So we will do that in different ways, different business units. We follow the same functional initiative of the federation are taken ahead via commercial service that we provide, and we participate in joint collaborative projects as the ones that we are participating with Mario Negri and other partners of the VERMEER project. So there are different topics that we are interested in this project. That's why and of course one is because we promoted the competitiveness. We want to call the company to further work on chemical developments because we really think that this will be fruitful services for the manufacturing base in Italy, and we really believe in this kind of projects, especially this one in silico tools, which require a cross of chemical knowledge with IT solution that we call often digital transformation, chemistry 4.0. This project is right in this kind of topics, multidisciplinary topic. And I think this is one of the difficulties of this project because it requires different competencies across each other, interface with each other. So this is the membership of Federchimica. I want to show that because there is a large representation, as you can see from the left percentage, which each of the subsectors, because Federchimica is composed of 17 sectorial associations from Cosmetica Italia, which is the cosmetics producers. Then we have, of course, the plastic, the base chemicals, the fibers, the technical gases, so many different. And a large part of this membership is composed, especially in Italy, more than Europe, by formulators. Formulators which are mixing up ingredients and individually are called to provide the safety data that are necessary to commercialize and exploit a product in the market. Here, I want to show that kind of the same information actually saw from different sides. So we have the organic and inorganic raw materials above. Then we have a complex value chain because from the base chemical producers, which are majorly represented maybe in Europe by the German producers. But then we have fine specialty chemicals, which are the right sectors that we are working with in this kind of project, because we're speaking about food contact material, cosmetics, as we saw, solvents. So all the components of formulating products that are delivering their innovative solution to the at the end of pipe, at the end of the value chain with the consumer industries. So you can see here that the share that we have in Italy is a little bit more proportionate on the kind of specialty producers more than basic chemicals, as we do not have so much raw materials, and we have a lot of manufacturing sectors that are exploiting those chemicals in order to finalize and sell their products. With these slides, I would like to mention that there are ongoing a lot of legislative evolutions in Europe with the European Green Deal, which is integrating different regulatory initiatives with different sectors, and including the last one that took place in last years with the Green Deal necessity to keep greener manufacturing base in Europe. So sustainability to point at that kind of drivers which consumers appreciate, and of course they are very important for the health of our citizens and not only about the economy. And in this case, I want just to finally mention another driver, which is the chemistry sustainability role. We know that chemical development is very important for the manufacturing base because of its ability to leverage on that kind of driver about consumer safety and sustainable productions, because this kind of products are the ones that are going to the consumers. And so the production is very important, the consumption is the same, very important. So we must take into account the health both of workers, but both of the consumers, both of the society, while maintaining in Europe a competitive manufacturing base. So all these mixing objectives are very important that should be aligned for enforcing our ability to continue to produce in Europe safe products for the both for human and for the environment. And here we come to the project, and where we I get in. Actually, I'm not a chemist, and I appreciate the content of the previous contribution, especially because this is quite difficult to really understand. I understand better the economic and financial topics, but this is very easy to be understood, because here on the right side you see some cost estimates in the tab. You will find the presentation. So when you will be able to deliver, if you want to check, you got the link on these kind of tables. And there is a presentation. I will try to open. No, sorry. I would like to open this kind of document which I placed inside. Maybe you will find that in this kind of document and table, I wanted just to identify the endpoints which are associated to each of the macro area, from physical-chemical properties to biological activities and environmental properties. As I'm learning, these are the tripartite list of the endpoints which must be compiled in terms of safety data needed for the chemical safety record to be advanced and approved for each product. And with this respect, it has been made some estimation of the costs of each of these endpoints, which is summarized in the table on the right of this slide. So there is a cost, and the cost is not only in terms of the test, even of the personnel managing, and we must be reminded of the solvents and the material needed for this cost test that are required by testing activities required by REACH compliance. These slides is just to remember what is the real problem. The risk associated is to a lot of substances that we release with our production activities, and so there is the strong need. In this evaluation, in this work we try to develop within Sviluppo Chimica, we didn't want to refer to the pollution risks, because this is much more difficult to quantify the baseline, which is the baseline in which we can differentiate and estimate what will be the impact of this kind of tools developments. If the tool were delivered and the market was able to use it efficiently and with validate estimates on safety data and new molecules, it would be still difficult to assess what would be the reduction of deaths in Europe because of the specific risk associated to these substances. And this is true for a lot of other pollutions, but we are aware that this will be the major lead of the regulation, and why we are working a lot on this kind of initiatives. We are aware that there will be significant savings, but for the moment, our wish, as we are working with industry, is to estimate what would be the impact on the industry. So that's why we wanted to remember that during the REACH regulation, as from its start, in the very start in 2006, after the 3 deadlines occurred, we obtained some data estimated by the companies. These are more precise, that each single company on average spends more than 1 million for the substances for the 3 deadlines combined. And most of the costs, significant part would be has been used for acquiring the license, the letter of access, the license to use the data, that experimental data gathered by someone other. And then, of course, there is a second component, very important, is all the time needed by the personnel. That could be the personnel or the consultancies. So there are significant costs that have been already expensed for the 3 past deadlines. But then we discovered that after the last deadline accomplished, this has been expired, we are still experiencing, as an industry, significant cost for the new products that are being delivered in the following month, year to the market, because this will require the new molecules will require dossier with that kind of safety data, and this could be so. This is our first objective to measure in this project, how the company could be impacted by this kind of tools in the red tape process that they must be executed during their development of new products. And not only the red tape. Then we learned that this kind of tools are very beneficial to the companies, to the knowledge for the new molecules, because they would help formulators to foresee in advance which would be the safer profile of a new compound. So the knowledge of the individual safety data through this kind of tools could make it easier to develop products with safer profiles. So in this slide, I just wanted to summarize all the kind of different benefits that could be encouraged and be gated through the implementation of the in silico tools platform, as we have seen in the previous presentation. So I would focus on the last, the below part of the slides, in which there are the benefits for the business because of the difficult estimation of the human health and the environmental benefit of reduced pollution. We are aware that these are the most significant part, probably, but we can better define what would be the short and long run benefits that a business would lead if they would improve their sustainability profile of the production. So the reduced R&D costs, of course, is a major item, because there are less, that there will be more ability to assess the hazard and risk to their product information, so the product that they are developing. And then, of course, this from it follows that there will be the increased competitiveness if the sustainability of European manufacturing industries will be reached and obtained through the implementation of these in silico tools. So then we will, of course, estimate the wider societal impact of such evolution. Chip screening, identification and substitution of dangerous chemicals, as shown with Toxiracer a few minutes ago, will be, of course, another important point, not only regulatory. So here comes the cost-benefit analysis, and then the specific benefit I reported below. I would point in this case to the improved R&D productivity and performance associated to that kind of implement in silico tools, because we learned that companies are not only requiring to fill up the chemical safety report, they must comply even with other regulations about logistics, safety data sheets that are going up and down during the value chain needed from the raw material producers. They must provide some ingredients, some products, and then they must provide the safety data within their value chain. So the chemical safety report could be then prepared by the company that below would market the product, produce the formulation. And then we have some other even filling in the, as we saw at the beginning, the PIF, or the vertical regulation that each required a specific safety data. And then I didn't mention here, I will mention afterwards, we have the NIAS, the non-intentionally added substances, which is another value chain, supply chain information request that could be filled up with these implementation tools with the platform. Here I wanted to report another report from Deloitte on chemistry 4.0 that is something different from what we are doing here actually, because this is specific for R&D and compliance. But we know, I just want to highlight that expectation are high on the right end of this kind of table in which you have the formulators. On the left side, you see petrochemicals, and then polymers, and then the paints, varnishes, fine specialty chemicals, which is the ones we discussed before. Here is the big impact, as you see the blue color in which Deloitte highlighted the impact. Where should be the impact of such digital transformation? I think this kind of projects, Silico tools, crossing chemical knowledge and ICT is really a good example for this kind of digital transformation. This is another way to summarize what has been the information emerged by the companies that started to ask information regarding these in silico tools. So in Federchemica, of course, we privileged some direct relationship with companies that are interested and willing to test this kind of tools. So we learned how company would, in some cases, exploit those information. As an example, another subsidiary of Federchemica is Centrorich. Centrorich is a company that, in a consultancy that is providing to the customer, chemical customers, some specific information regarding those filling up of chemical safety report, but not only, even safety data sheet, as said before. And then another specific company, formulators from the specific sector, told us that they were using the VERMEER tools to better understand what will be the safety data of not intentionally at the substance which they were called to provide to their clients base. So this is something that could be maybe recognized as a customer fidelization, I wanted to call it in the slide. I mean, this provision of data could make the difference for the final chemical safety report filling by the customer. So it could be another instrument to which customers could be fidelized in our view. So there is some other impacts that we wanted to identify. I didn't say before, sorry if I go back and forth, but I wanted to mention that in Cosmetica, of course, there's a product regulation well ahead, like food contact material is maybe a second, another sector that is going fast in this kind of research of safety information. But probably there will be more that will gather and recover the distance from these advanced sectors. And this is why our initial efforts, referring to the project, VERMEER, have been directed to the cosmetic industry, in which there will be the clear rule not to use any more animal for their research in order to make in vivo analysis. So they wanted to substitute. In the same moment, actually, we have other sectors that are not completely aligned with that effort, because they're not sure what is the evidence, how this data will be used. So an important point is that this in silico data will be more and more accepted to when the chemical safety record will be filled with. And this is something that we are trying to do to promote with the federation and in other tables, with institutional tables, trying to support. But like Sviluppo Chimica here, we want just to provide some data estimate of what would be the saving of the formulating sector. So we started from cosmetics because we, in 2019, Cosmetic Italia developed the research. And here you can see which is the average intensity of innovation expenses by cosmetic sector. The cosmetic sector expended almost 6% of their turnover in 2019. And this in percentage, of course, is even larger in some companies, particularly innovative. So this, I try to detail these components on the right end of the slide, and this should be seen not anymore as a cosmetic. I wanted to generalize on formulating sectors. Maybe the percentage is a little bit less, because in the left side you see there is a component which is the purchase of equipment, machinery, and software and building. Of course, this is not the component we want to make savings, because this component is when you buy innovation with equipment, when you make some technical investment, but not develop internally. We want to recognize which components were on average expensed internally, because from this base we can have an estimate of how in silico tools could change and the ability of the companies to develop new products and formulates. So you can see the detail of the components of the cost that are faced by companies during their R&D development. And this is, so the percentage on total has been estimated as 4.5%. This 4.5% actually has different, so the subcomponents, as you can see, the greener are estimated to be actually be reduced by the implementation of in silico tools, because with in silico tools you have an automatic instrument provided, so you have less personnel cost, for sure less material, solvents and laboratory, because you are not anymore developing the test. You will reduce the external cost of letter of access, because you will develop your own data, even if forecasted. And then you have, of course, less consultants and less external costs. What you will maybe bear more is more training, because these tools are very complex and need some training, as we have seen before with Marionette. And at the end of the day, the end of this reasoning, we try to select the specialty chemical sectors, as you see highlighted on the left table, in which there are a lot of formulators. But actually, the potential destiny of the exploiting such tools could be even recognized in other sectors. So that's why we estimated the total of R&D expenditure that we can generalize the chemical companies, as they have special attention on R&D, and therefore they could be exploiting those tools in a very efficient way. And these are the three scenarios that have been modeled with different percentage of saving opportunities on that amount related to the different level of implementation. So the implementation could be touch only a few companies that are front runners, or they could be maybe accepted, and progressively, hopefully, they could be used by the majority of them, with providing a larger expected saving. The main hypothesis I made is that the performance of R&D should be the same as we know. So to reach the same number of new products, we must expend less monies. But it could be of course, the reality will not be like this. We know already that companies probably will develop more R&D projects. So this is, I will say, like a first hypothesis in which we wanted just to quantify what would be the saving if we want to reach the same performance of R&D. But probably when these tools will be used by companies, we will see more efforts on the R&D because they could lead to further production that could be more sustainable, could even improve the performance of the overall manufacturing base in Europe. So, and this is just to show what will be the performance at the European level. I took the CEFIC data. Within the CEFIC data, you see the yellow specialty chemical producer, and then on the right hand, the estimates of the same percentage in which we think that could be made assumption about the saving opportunities as made it before. So this could be the amounts that could be saved with the different progressive implementation percentage as made before for the three scenario analysis. And this is the end of the presentation. I hope that I've been in time. Gianluca, is it okay?